Piney Creek Power Plant, reclaiming the past with a promising future. Mining practices prior to the 1970s resulted in thousands of acres of idle accumulations of waste coal. As time progressed, natural environmental processes enabled the negative expansion of waste coal components into our lands and streams of multiple values. These abandoned mines and more than 1 million tons of waste coal contributed to the miles of once pristine streams, intoxicated by acid mine drainage today. Laws were passed near the end of the 1970s era, requiring the reclamation of all currently mined sites. However, billions of tons of waste coal, acres of abandoned mines, and environmental degradation from previous generations remained, as the formerly responsible companies had perished. However, just a decade prior to the turn of this century, the key to reclamation of waste coal arose. Thought to be impossible by the uninformed and deemed an environmental turning point for the coal industry. With the invention of circulating fluidized bed technology, power plants such as Piney Creek are able to remove the refuse piles associated with landscape degradation while simultaneously producing clean electricity. The Piney Creek Power Plant operates in accordance with the Title V Air Quality Operating Permit imposed by the EPA. By utilizing a continuous emissions monitoring system, qualified employees can ensure that the plant meets the set emissions standards, ultimately operating under the suggested amount proposed by the EPA. The continuous emissions monitoring system is calibrated daily, with failed calibrations red flagged. Calibrations must be manually reset if the system calls for such. Just prior to steam exiting the stack, a sample of flue gas flows through a line where it is subjected to sulfur dioxide, nitrous oxides, carbon monoxide, and carbon dioxide emissions analysis. Results from the analysis are sent to the plant's single server to aid in calculations and are monitored continuously in the control room. Matt Hawkins, Piney Creek's environmental manager, will thoroughly explain the components of the control room.
We're able to monitor fuel feed, limestone feed, plus we have our emissions here, which is opacity, sulfur emissions, NOx emissions, and the oxygen we just use for boiler control. This SO2 average here is the average over the past hour. So we're averaging it out, and the SO2I is the instantaneous. So that's what we're putting out right now in pounds per million BTU.
Piney Creek Power Plant is non-traditional when compared to a majority of pulverized power plants nationwide. Instead of obtaining coal from newly mined areas, Piney Creek burns the waste coal piles that have accumulated over the decades. To control nitrous oxide emissions, Piney keeps the temperature of the fluidized bed less than 1650 degrees Fahrenheit, as low temperatures decrease the chance of nitrogen formation. As the coal burns, it is mixed by the fluidized technology, as opposed to being ignited upon entering the furnace. During this time, the waste coal particles are mixed with limestone, which is blown directly into the combustor, averaging 7 tons of limestone addition per hour. Limestone captures the sulfur oxide during formation. The process is repeated and the fuel and limestone particles are recycled numerous times. Repeating the process with the same materials allows for high efficiency burning, greater gaseous emissions capturing, and high quality steam, which is needed to turn the turbine for electric generation.
The coal we burn is waste coal, which is actually high in a sulfur content, but by using limestone mixed with the bed, we're able to maintain the lower sulfur amounts.
The components of the CFB technology enable combustion of almost any combustible material. Piney Creek plans to increase their combustion of wood chips as biomass to 10% or more to address the rising concerns of carbon dioxide emissions. Regulations for carbon dioxide emissions just recently became a concern. Unlike older operating plants, Piney Creek was proactive in emission control and installed a brand new carbon dioxide monitor. After combustion, the flue gas enters the baghouse, which consists of 8 cells and 256 membrane-pleated cartridges. The flue gas enters the baghouse, and the high-efficiency cartridges aid in the removal of particulates. The efficiency of the membranes is such that the flue gas enters the baghouse, but heat and water vapor are the main components of the steam that is expelled from the stack. Of course, with production of any fossil fuel-based electric generation facility, byproducts of combustion remain when the process is completed. Fly ash is an alkaline byproduct of CFB combustion. The material is non-combustible and receives a lot of unnecessary negative attention. While fly ash does contain trace levels of elements such as mercury and arsenic, the general consensus seems to be that power plants have created these toxins. In reality, the elements are present in the natural environment regardless of coal combustion. The elements are concentrated in the fly ash, but no excess is produced during combustion. Fly ash is subject to leachate tests at Piney Creek, and the results of these tests are reported to the appropriate departments of environmental protection. Piney Creek stores fly ash in 2 large silos, with a virtually dry consistency, steering clear of impoundment ponds and ash slurries. Fly ash has proven itself to be beneficial by its ability to be utilized in numerous areas, such as mine reclamation projects, lime replacement in areas affected by AMD, soil amendment, as a concrete additive, and in pipes and roadway bedding. Piney Creek's General Plant Manager, Kendall Reed, speaks on behalf of the plant.
Our plant was created to burn these piles and dispose of them, and in doing that we create an alkaline ash that can then be used as reclamation of the mining sites, both existing and legacy piles and sites across western Pennsylvania. Piney Creek's been doing this now for a number of years and have reclaimed thousands of acres in abandoned mine areas, and we'd like to continue to do this. We feel we present a very economically feasible solution to the problem of acid mine leakage and these abandoned piles.
With the coal industry taking the generating responsibility for 50% of the electricity you use today, be mindful of the practices and efforts set forth to support a quality environment. How fortunate we are to have a facility that truly cares about the condition of the environment and its people. How unfortunate the negative connotation and instantaneous grouping of all power generating plants into one common misconception.